Today is our fourth session. The first 2 days we have spent in dealing significantly on R. We have executed a lot of R code. And yesterday we have gotten started with statistical analysis. Today also we are going to spend a lot of time on statistical analysis. So yesterday I had one question for you all. I wanted you all to solve this problem, right? Standard deviation, SD of x1 plus x2. What would that formula be here? Did you guys get a chance to look into this? Anyone? Yep. So what's the answer for that, Aditya?
So, yeah, it would be the combination of that, assuming we know the sample.
Sorry?
Do the first S1 square, or the first variance 1 plus N2 minus 1 into variance for the second sample divided by the total sample size minus 2.
Can you help by chatting so that everyone else benefits from that?
Okay.
Can't hear anything? You all are able to hear me, right? Enoch is not able to hear. Are you guys able to hear me? Yep, Monica is able to hear. So, Enoch, please check the connection at your end. Everyone else is able to hear me. So for everyone else, please try to find out what the formula is for this. I'm not going to tell you what is the right formula here. And Aditya is trying to type and provide you with an answer, but you'll have to evaluate from your end and check whether that is the right answer or not. Please invest some time from your end, otherwise it might be difficult to grasp the concepts. All right, so there you go. There's the formula which so I'm not going to tell you whether this is the right answer or not, but you guys have to try from your end and check. All right. Yeah, you're right on that, Aditya. There is no direct answer available, even in Google, you'll not be able to find, right? Okay, sure, Enoch. Enoch seems to be having a problem there. All right. Let us continue from where we have left. We have completed the session until here. So what are the various things that we have looked into yesterday? We have looked into what are the 4 data types, namely nominal, ordinal, interval, and ratio. From there on, we have moved to discuss about the random variable concept. Then we have discussed about probability distribution, the discrete distribution, and continuous distribution. Then we have spent some time calculating the expected value or mean, variance, and standard deviation, range, right? We have tried to quickly look into the concept of population and sample. We know that all your population parameters are calculated using Greek notations, and all your sample statistics, the notations used were not Greek. Then we have looked into graphical representations such as bar chart, box plot, histogram, and then we have tried to calculate or infer on what does skewness mean and what does kurtosis mean. We have discussed about all that, right? And then we have discussed briefly about the characteristics of normal distribution. What is a normal distribution, right? Yeah, absolutely. Skewness and kurtosis are the third and the fourth moment business decisions, which we take, right? Question to you all. What is the area under the entire curve? Area under this entire curve is equal to how much? 1. Absolutely. Good that you remember that. And then we have discussed about how to calculate the p-value or the probability using R, using z-score, which is called as standardizing or standard normal distribution, right? And how to calculate the same using MS Excel. There is a function called normal distribution, norm dist, and then we could successfully calculate the p-value there. And then we have calculated even this exercise. Now there is another exercise which is going to come up now. Here we go. Enoch, are you able to hear me now? All right. So I've muted you from my end. Great. Okay, just to motivate you all further, one of our past participant, he had 2 years of experience. Now he is placed in a company for 10 lakhs per annum. 2 years and 10 lakhs per annum. That's amazing, right? So this very course that you are undergoing is worth everything for you all. So please invest equal amount of time from your end. There's a huge potential even for freshers. There's an extremely huge potential, and that person was naive to analytics when he has joined this session. And this session, whatever we have planned, includes everything, all the finer nuances which one might ask you in an interview. For people who have, say, 5-6 years experience in statistics or analytics, this is what they learn, right? So they make best use of this program. Okay, here we have the second exercise. We need to calculate what is a probability that X, what is X here? It has a name. What is that called as? Random variable. What is the probability that X lies between these two numbers? How do you calculate that? You simply draw a curve. What was the mean? Let me check there. Okay, let us calculate here only for that. So we wanted to calculate, say here is the mean. We wanted to calculate the probability that X, capital X, lies between 740. Obviously 740 would be somewhere here. Can I say so approximately for our understanding? Can I say that 440 would be towards the right? Yep. And where would 697 fall? 697 would that be towards the right of the mean or left of the mean? Just before 700. So can I drop a line here? You're telling that is my 697. When I calculate the probability of capital X, is less than 740, that would be this region, entire region from 740 until here. If I calculate probability of something or capital X lying below 697, I would get this region, right? This region. And if I subtract this region from the 740, I would obviously be left with this region. This is the area of interest for us. Simple mathematical notation, right? How do you write this? P of X less than or equal to 740. That's 740 there. And P of X less than or equal to 697. If I calculate these two probabilities separately and subtract from each other, I'll get this. And apply the same technique that we have applied yesterday, either use a P norm or Q norm or whatever be it, right? So let us do that. Let us do that using R, because from now on R would be a tool or whatever. P norm of what is the value that we are interested in? X, mu, and standard deviation. What was the X which we are interested in? We want to know the probability which is less than 740 there. What is the mean? From the previous example, mean turns out to be 711 and standard deviation turns out to be 29. That's 0.84. Let us see whether it's matching here or not. Yeah, there we go, 0.84. If you all are wondering on where I've got that 711 from, here, the previous problem. It's the continuation of the previous problem. So I have the mean as 711 and the standard deviation as 29. How do I calculate the probability of X less than or equal to 697? How do I calculate that? Someone? Let me know the P norm. You can chat with me. Let me know what should the P norm be. P norm of what is our command? Absolutely. P norm of 697. Simple application of formula, that's it. 711 is the mean and 29. All these three values are provided to us. We are just using this command which says P norm. There you go, 0.31. And here we have probability that capital X, random variable capital X, is less than or equal to 740. And there you get 53%. How am I getting Z value as 1 here? How am I getting that? What is the formula for Z? Z is equal to X minus mu, yeah, right, divided by standard deviation, that's mu. Why is it not coming? All right. What is X value here? 740 minus mean is 711. Standard deviation is 29. Tell me what would the ultimate answer be here? It's 29 by 29, which would be 1. How did we get 0.5 here? Same formula. Z is equal to X minus mu by standard deviation. What is the value of X? It's 697 minus 711 divided by 29. You'll end up with this. Is that wrong? Anyways, yeah. So if you know the Z value, how can I find out probability there? If I know the Z value, how do I calculate the probability? Anyone? How did we calculate that yesterday? Z table. That's a simple thing, right? Z. What is a Z of 1? Where is 1 gone? Here it is. It's 0.84. Isn't that the value which we have here at 0.84? What is the Z value for minus 0.5? Minus 0.5, it's 0.3085, which will be 0.31 if I round it off, right? 0.31. Done. You get the answer. Clear, friends, on how to calculate the probability using R or Z table or using your Excel. Please go through each recording the next day. That is pivotal to your success. Please do that. Try to get that time somehow. Only then you're going to strengthen your profile, right? Otherwise, it's no use. It would be one of those courses that you would have undergone in the past. Okay. All the while we have been discussing about normal distribution, right? If something follows normal distribution, your statistical calculations from there on would become extremely easy for you. Hence, we try to check on what is the distribution of the data set that we are dealing with. If the data follows normal distribution, your analysis would become that much easy. That is the only logic, right? Nothing else. And we have a supporting algorithm which is going to come now, a theorem for that case, right? So this is the normal quantile QQ plot. What does this QQ plot mean? This is a straight line. Oh, sorry. This is a straight line. If these data points fall along this line, on the line, or very close to this particular line, you call this as normal distribution. If the data points, all these data points are your GMAT scores of various people, GMAT scores, that's it. These are all your GMAT scores of 773 students. How do I plot this on R? That's the question, right? So let me go to R. There are a lot of commands. If you wish to do along with me, you're free to do that. If not, you can focus now and then try to replicate the commands at a later point of time, right? So there's MBA dataset here. And we know that this MBA dataset has 773 observations of 3 variables. So there are 3 variables: work experience, GMAT, and you have the serial number. And you have 773 observations. Right? And if we run the command, this is a command, right? And even before I run the command, I need to install a package called extremes. That's the package name. Let me enter that. What happened? Where did I go wrong? So starting the session, let me see what happens. Yeah, this red dot here says that an operation is in progress. If you want to halt it in between, you can click on that. Once you install a package, we need to load the package. Library of extremes. Yes, R is case sensitive, Enoch. It's very case sensitive. Okay, so that's the package name there, extremes. We have loaded that. This package is required for us to come up with this plot. Let me erase the previous plot so that it's not going to disturb you there. Okay, the first command that we wish to run is this QQ norm of the variable. Say I want to do that on GMAT, so I need to say from this MBA dataset, MBA variable, MBA file, I want to call GMAT variable. So I'll do a dollar GMAT. There you go. But what did we discuss? We have discussed about these data points falling closer to this line. Where is the line there? It's not there. So let us draw this particular line. The command to draw the line is QQ line, MBA $GMAT, and say I want to represent that with a red color so that it appears clearly. There you go. That's the red line. If these data points are closer to this line, you can call that the data follows normal distribution. In this case, you say that, hey, data does not follow normal distribution, maybe, right? But we can also have bands, right? We give some flexibility. We are not sure, or only if the data points fall exactly on the line, right? That is not the only time when we call that the data follows normal distribution. It might be closer to this red line. And what is closer? What does that mean? In order to know how close these data points should be to the line for me to call that the data set follows normal distribution, all I'm going to do now is put some bands. I'm going to give some, what do you call, limits within which the data point should fall for me to claim that the data follows normal distribution. And for this, there is a direct command which says qqplot MBA $GMAT, and I'm saying that I'm checking on the distribution of norm. When you run this command from your end, you'll obviously get an error, and the reason being you need to install this package called car. There's a package called car. You need to install that. So let me run that command, which is car. Right? You need to run that. I'm not running it for you because I have already done that, and I've also loaded this package called car. Companion to applied regression. That's the abbreviation of this package. Do you need to know the abbreviation of these packages? Not required. But good to know, right? Good to know the frequently used packages. It's going to give you an additional edge in the interviews, because if you have really worked on these things for a greater duration of time, you would obviously know this, right? So it's always better to know this. Not required though. All right. Questions might be around, hey, which package do you install in order to calculate your QQ norm, QQ plot? You need to provide these package names. That's it. Okay. So here is a plot. If your data points fall within these bands, red bands which you're seeing, right? Then you call that the data follows normal distribution. But however, here we have a lot of data points which are falling outside the band. A bunch here, 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 right? Everywhere. Most of the places, most of the data points are falling outside these bands. Hence, you call this as not following a normal distribution. Simple. This is one small thing which we have already discussed, right? We have discussed that, hey, if you have a population, I do not have the time and energy to, sorry, do we just go by the eye to judge if it's normal or not? We can, Enoch, we can visually also judge whether data follows normal distribution or not. However, there's something called as Anderson-Darling normality test, which we're going to discuss. Probably in today's session itself, you might come across that. That's one way of analyzing on whether your data follows normal distribution or not, right? Based on your experience, you'll be able to quickly find out. Yeah. AD test, Aditya. AD test, we can do it in R also, but I'm going to do it on Minitab because it's going to be time consuming otherwise, right? But R code is available for that. Yeah. So here we have the population. Whenever you're calculating central tendency, that is mean, or measures of dispersion, which is variance, or when you try to calculate the proportion for a population, we use what notations? Greek notations. And always you call this as population parameters. Population parameters, right? So I have a population. I obviously do not have the time and energy at my disposal to go and survey or try to find out details from the entire population. If I ask you a simple thing, hey, go quickly do a survey of all the Maruti Swift cars and let me know how many people are satisfied with the cost of the car. That's my simple statement. Go and find out from all the Maruti Swift car owners on whether they are satisfied with the price of the car or not. Would you be able to complete this exercise within a year at least? You will have to start right from Jammu and Kashmir, right? You will have to come all the way until south down, and you will have to go and do an interview with each and every person. If you call a person, he might say, I'm extremely busy, call me tomorrow or day after or 10 days down the line. Or a few people might be yelling at you if they're really disappointed with the service. So it would not be feasible for me to go and survey each and every person to get the details, right? Based on my business objective, I cannot do that. So what do? I do a random selection using what technique? The technique is called a simple random sampling. It's blindfolded. I close my eye and pick few customers, go and check with them. That is called a sample. Based on sample, I calculate sample statistic. Remember here you call that as population parameter, here sample statistic. I'm stressing on this because if I were to interview someone, I would just ask them in this way. What are the population statistics that you are aware of? And if the person answers, that means he doesn't know things, right? Or I would put it in this way. What are the sample parameters that you are aware of? If that person says sample parameters are mean, variance, proportion, x bar, s square, and p, then I would probably be forced to reject that profile, right? So you have to be clear on these things. Simple but required. So these are the sample statistics. The notations used here are not Greek notations at all. Okay. Now, whatever inferences I draw from this sample would be applicable to my entire population. Let us move forward with that understanding. Now, what is simple random sampling? As I've told you, it's blindfolded. I'm going to close my eyes and just pick you, and things like that. Right? Here, it's unbiased because there is an equal chance of each unit being chosen in the sample. There is an equal chance. That's the good part, right? And selection of one unit has no influence on selection of other units. I'm selecting this person, right? Does not mean the next person that I'm going to choose will be this person, second person, right? Selecting one person or one unit has no influence on how you're going to select the rest of the units. And this is the gold standard against which all samples are measured. Here there's another concept called a sampling frame. For example, I might do a simple sampling frame here. What would that be? Think about this, right? So there is this population, all the users in entire country or across the globe who have iPhones, all the customers across the globe who have iPhones. I want to quickly perform a survey and check how many people are dissatisfied with iPhone 6 Plus. There are a lot of reviews coming in, and people are saying that the screen is bending, it's breaking, and things like that, right? So I want to really understand whether those statements are true or not. So I have the entire population here of iPhone users. Obviously, I cannot go and, find out from each and every iPhone user. That would be a Herculean task. So what would I do? I would take a chunk of this and call that a sample frame. I would say, all right, let me do a survey, but I'm going to do the survey only in US because most of the iPhone users are currently located in US. That is called a sampling frame. I decide a sampling frame out of population. From this, I pick a sample, probably 10% of this or 20%, whatever be it, right? And in subsequent slides, we'll come to know on what should the sample size be, right? So we pick up a sample from the sampling frame using simple random sampling. And then I do analysis on this. Is this clear, this flow on how you select a sample? Probably I need to make small changes here. I'll say that, hey, you use simple random sampling technique to come up with a sample. Friends, do you have any doubts here? Until now, based on whatever we have discussed until now. Anyone? No doubts? No one else is answering, so should I assume that you all are not listening to the session, or what do we infer from this? All right, thank you. How to define a sample frame? That's dependent upon, Aditya, on your business problem that you're trying to solve. Right, maybe it all depends on your business problem, right? What is the kind of problem that you're trying to solve, and it requires a lot of brainstorming and things like that. I'm just trying to think about an example here. For example, if someone says that, hey, there are a lot of complaints coming in from African continent, then for me to do a survey, I might select the sample frame as Africa. Out of the entire population, I might select only Africa there, and then do a sampling on that. If you want to know, hey, what are the locations where I need to come up with Apple Store, then again, probably my sample frame might vary. I might do sampling only on, say, tier 1 locations, or those locations where internet penetration and the awareness of the smartphones is more, probably to increase my sales. Or if I want to position myself as a market leader in a particular region, then probably, and that is when I want to go first to that location, right? Say there is Vizag. There's a huge, or there's a high chance that IT might grow in Vizag. That means there's a huge potential for the smartphone market there. If there's no one, I'll go there and try to set up my shop first there. So probably that location might be, or all the tier 2 locations might be my sampling frame. So your sampling frame always dependent on what is the business problem that you're trying to solve. All right, look at this. Like geographies, clusters, right? If I want to increase my footprint in a different geographical location, probably my sampling frame will vary there. It all depends, right? In mergers and acquisitions, your sampling frame will vary. If you say that, hey, I want to acquire a company who's who is willing to be sold out for $1 million or less than that, probably my sampling frame is going to vary in that way, right? Okay, so sampling frame is simply a list of items from which to draw a sample. Yeah, it can be a company, yes, absolutely. The type of companies, for example, if we are ExcelR solutions and if we want to acquire a company, we would not acquire maybe a company which is already into learning services, right, or consulting services. Probably we'll go and venture into Internet of Things or cloud computing or analytics firm, which is very new and niche because we want to increase our footprint in the various other regions. Maybe it all depends again. All right. So here's the second point. Does the sampling frame represent the population? For example, any market research, Gallup, for example, does a lot of surveys, right? And it tells on how the employees of an organization are reacting. For example, in Infosys, every annum, every year, Gallup was a research organization which used to send us a survey, right? And we were all expected to fill in the survey questions. There would be 10, 20 questions. Based on that, they would assess the health of the organization from employees' perspective. And they would come up with the corrective actions and things like that. Now, all 1,20,000 or 30,000 or employees of Infosys would not take the survey for various reasons. I might be on leave, on a long leave. I might be deployed at a client location. Maybe I do not have access to internet, to Infosys emails. Or maybe I do not want to take the survey because I feel that I'm extremely satisfied. Or maybe I feel that people are not going to anyways take action, maybe. So just because I'm sending the survey to the entire population does not mean entire population is going to answer. Always it would be a sample. And this sample would be analyzed. However, the statements would be made about the entire population. Here, the available list may vary from the desired list. Probably we don't have list of customers who did not buy from a store, right? So who are we analyzing? We are analyzing only those customers who are purchasing from our store. Probably that is my sample frame. If that is the case, we don't have any clue on the buying habits of the customer who doesn't come to your store. How would you convert a customer who's not coming to your store to come and purchase at your store? Right? This is most important, right? People are coming to your store would probably continue coming, right? How do you increase your base, customer base? Only if the outside person who is going to a different store comes to your store. So this is a challenge when you do the sampling frame, right? You do only on this. Sometimes no comprehensive sampling frame exists. Well, there might be a lot of parameters which one has to consider even before selecting a sampling frame. So these are all the key points about sampling frame which one should be aware of. There is a question from Aditya. Any exercises that you have for as homework on what, Aditya, on selecting the sampling frame? Oh, it's very, very subjective. You cannot arrive at that, right? Even if I have a business problem, you might have a different sampling frame. I might have a different sampling frame. My thought process would say, hey, go with this continent. Your thought process would say, go with another continent, right? What if I give you a case study from financial services insurance, from Australian region? They have different rules. Australian Prudential Regulatory Authority, APRA. So they'll have APRA, right? Those will follow some other standards. So your sampling frame might vary based on that. If I give you a sampling frame or exercise for a client who is based out of India, you might have a different sampling frame because of the population, and all the various details. So it's not going to be a straightforward game there. I'll try to find out, Aditya, if I can get hold of few of those, I can share it with you along with the answers, because your answers might vary and there is no right answer here. Okay, sampling. How can a sampling exercise go wrong? If you collect the data only from volunteers, for example, who are the people who are going to report on TripAdvisor? Someone who is very interested in trips, in exploring the world and things like that. Maps.google.com, right? How do you think these maps and the locations on the Google map gets updated? Do you think Google is going to sit down, go and check each and every shop, try to find out the details and then enter online across the globe? Or how do you think Google Maps get updated with the locations? It's we, right? People whoever are interested. If say I want someone to quickly identify where ExcelR Solutions office is in Hyderabad and Bengaluru, what do? We proactively create an entry on the Google map so that if someone searches, they can easily trace out where where ExcelR Solutions is, right? So if you're collecting data, only from volunteers, then your analysis might go wrong. If you're picking easily available respondents, I'll come to that, Aditya. Picking easily available respondents. That means if I ask you to do a quick survey, you might go to a mall or you might go to a location which is close by to you, right? Probably you'll go to Inorbit Mall because that's very close to you all. That means you're being very choosy and you're choosing nearest location. So sampling is biased. Once again, it's wrong. It's going to be giving you wrong indications there. And look at this, a high rate of non-response. CIO.com or your so-called CIO CEO websites, they publish a lot of survey results on the industry trends. And each survey would contain approximately 50, 60 odd questions. It would take 2 hours, 1 to 2 hours, right? At least to complete the survey. Do you think your CEOs would be so free that they're going to sit down and fill the survey questions worth 2 hours? May not be, right? Most people are not going to respond. Even if they are going to respond, I'm going to ask one question. Who is the CEO who has 2 hours of time, free time to fill a survey? Do I need to rely on that? I don't know. So your survey might go wrong um, in all these 3 cases. Sorry, your sampling technique might go wrong in all of these 3 techniques. Yeah, absolutely, Aditya. Selecting the right sample frame is extremely important. And Aditya has made the statement that, but if we leave it to everyone, that would be population. What does that mean, Aditya? So are you telling me that I didn't get you? Can you come again? If say 1 million people are volunteering to enter their company details or location details on Google Maps, say 1 million people, this is my population absolutely. From this, I'm going to take a sample out. Probably 10% of this or 20% of this, right? That would be the sample. Is that your question? Yeah. All right. So let's proceed further. Sampling variation. Mean or the average of the sample might vary from one sample to another. Say this is your population, a simple exercise here. And you are picking up how many samples here? 6 samples. Sample number 1, sample 2, sample 3, sample 4, sample 5, and sample 6. And what is the size of the sample here? The size is 2. Sample size is 2. So if I take the average of this sample, it would be 29. If I take the sample mean for this sample, I'm going to get 30. If I take mean of this sample, I'm going to get 33, so on and so forth. So sample mean varies from one sample to another. Also, sample mean can be and most likely would be different from the population mean. What is your population? It's there here. So if I take an average, 26 plus 32 plus 34 plus 40 divided by 4, that would give me the average for the population. This average and the averages calculated for each sample can be different, and most often than not, it would be different. And sample mean is a random variable. That means I have 1 by 6 probability. So if I'm taking 6 samples, right, I can get 6 different values. What is the probability that I'm going to get 29? It will be 1 by 6. Think about this as rolling a dice, right? If I roll a dice, I would get 1, 2, 3, 4, 5, or 6, right? So I have 6 possible values which I might get, right? Each time the probability associated with each number is 1 by 6. Here it's 1 by 6. There it's 1 by 6. Here it's 1 by 6 in that way, in that sense.